The world's biggest technology companies just committed hundreds of billions of dollars to build the future of artificial intelligence. And then something strange happened. Microsoft quietly walked away from 2 gigawatts of planned data center capacity. OpenAI halted the expansion of Stargate, the AI megaproject announced at the White House as the largest infrastructure investment in history. Across the United States, new data center construction suddenly dropped by 50%. But none of this makes sense. AI demand is still exploding. NVIDIA is shipping chips, cloud companies are reporting record revenue. So why are the biggest AI projects suddenly slowing down? But the real story has very little to do with AI. In early 2025, something unprecedented happened. Google, Amazon, Meta, and Microsoft all made the same bet at almost the same time. Together, they committed over $300 billion to building AI infrastructure in 2025 alone. And this wasn't a forecast or an analyst estimate. These were real spending plans shared directly with investors. The logic behind it was simple. AI doesn't run on ideas, it runs on raw processing power. And that power isn't abstract, it physically exists inside data centers. And whoever controls the most compute ends up controlling the most powerful AI. That idea quietly turned into an arms race. And once it started, no one could afford to slow down. Then the scale increased again. A new project called Stargate was announced. It was a joint venture between OpenAI, Oracle, and SoftBank. The announcement happened at the White House in early 2025. $500 billion AI infrastructure program, the largest of its kind ever attempted. Construction began almost immediately. Thousands of workers were on site, building around the clock. At the same time, every major hyperscaler was moving in the same direction, trying to secure more capacity, to build faster than everyone else, and to avoid falling behind in what had quickly become the most expensive race in tech history. By mid-2025, the momentum looked impossible to stop. But within months, something unexpected started happening across North America. Data centers were almost completely full. Vacancy rates had fallen to just 1.4%, an all-time low. In simple terms, nearly every gigawatt of existing capacity was already in use. For the first time, demand wasn't the issue anymore. Analysts from Bloomberg, Sightline Climate, and others began pointing to the same issue. The chips weren't the problem, neither was the land. The real bottleneck was the electrical infrastructure. 3 components in particular kept showing up: high-voltage transformers, switchgear, and grid connection systems. These are the parts that actually connect a data center to the power grid. Without them, even a fully built facility cannot turn on. It can be completely finished, fully funded, and ready to operate, and still receive zero electricity. And the problem is getting worse. Before 2020, a large power transformer could take about 2 years to manufacture. Today, that timeline has stretched to as long as 5 years. Prices have surged, manufacturers are backlogged, and orders keep piling up, which creates a strange situation. A project worth billions of dollars can be delayed by a single component that costs only a few million. At first, the transformer shortage looked like a simple supply issue, a manufacturing bottleneck, something that could be solved with time and more production. But there was another layer to the problem, and it was geopolitical. Today, China dominates global transformer manufacturing capacity. For years, that fact didn't matter much. Transformers were seen as industrial components. They moved quietly through global supply chains without much attention. Then the AI build-out began, and everything started to move at the same time. US imports of high-capacity transformers from China exploded. From fewer than 1,500 units in 2022 to more than 8,000 units in 2025. And just as demand peaked, tariffs were introduced. That combination changed the entire system. Lead times stretched further, prices climbed faster, and existing orders started to pile up across the industry. As one analyst put it, capital can move instantly, but physical supply chains cannot. By this point, the problem had become unavoidable. Even massive budgets could not fix the delays. Even approved projects were stuck waiting for power connections that took years to complete. And the companies building AI infrastructure reached a simple conclusion. The system itself was too slow. Instead of relying on the public power grid, companies would generate electricity directly on-site. That meant building their own power sources. Gas turbines, fuel cells, and in some cases, even planning for small nuclear reactors. All connected directly to their data centers. OpenAI's Stargate partners in Texas took one of the most aggressive steps. They ordered hundreds of gas-powered reciprocating engines, enough to generate more than 2.5 gigawatts for a single campus. Google took a different approach. Instead of building all the power themselves, they agreed to something unusual. They would automatically reduce AI workloads during peak electricity demand. In exchange, they would get faster approval to connect to the grid. Two completely different strategies, but the logic behind both was the same. If the grid cannot move faster, you redesign how you connect to it. There is one problem, however. This approach is extremely expensive. Behind-the-meter power can cost roughly twice as much per gigawatt as traditional infrastructure. But in this race, cost is no longer the deciding factor, because time has become the most valuable resource. For the past 30 years, every major limit in computing had one kind of solution. Processors got smaller, memory got cheaper, bandwidth got faster, and storage became almost infinite. And every time, the industry simply engineered its way around the problem. And now, AI has broken that pattern. For the first time, computing is no longer just a digital problem. It has become physical. It depends on steel, on supply chains, on power grids that were never designed for this scale. The winners of the next phase will not be the ones who committed the most capital. They'll be the ones that solve the energy equation first. Hundreds of billions of dollars are ready to be spent. The chips are ready, the sites are designed. But the AI race isn't slowing down because companies are losing confidence. It's slowing down because power grids, supply chains, and physics don't care about earnings calls. As the AI race continues, we'll keep breaking it down. Subscribe for more.